Hi, my name is Gianna Cataloni, and this is my Chemistry 120, Experiment 1, What's in the Water. The purpose of What's in the Water was to determine what functional groups were in the unknown substances, and then to eventually determine what molecule our substance was. IR, infrared spectroscopy, and NMR, nuclear magnetic resonance spectroscopy, were found in order to determine what the substance was. IR spectroscopy measures the amount of electromagnetic radiation that is absorbed by a sample. In IR, the absorption of a photon in the infrared region leads to an increase in the energy of a molecular vibration. Electrons are not affected. The more complex the molecule, the more vibrations in H atoms it will have, and the more absorption peaks it will have. NMR spectroscopy measures the amount of electromagnetic radiation that is absorbed by a sample. In NMR, the absorption of a photon in the radio frequency region leads to excitation of a hydrogen nucleus, the proton. The more complex the molecule, the more vibrations in H atoms it will have, and the more absorption peaks it will have. In this experiment, IR and NMR spectroscopy were found in order to determine what molecules the substances are. To find the IR spectroscopy, the unknown substance was placed onto the glass plate, and this was then placed into the Nicolette IS5 spectrometer. The graph for this unknown substances was printed out so it could be compared to the graph 4.2 in the laboratory manual. To find the NMR spectroscopy, the unknown substance was placed into the EFT60 spectrometer. The graph for this unknown substance was printed out so it could be compared to the graph 4.3 in the laboratory manual. Table 1 shows the different functional groups that are in each molecule. Table 2 shows the number of peaks and the ratio of areas that are in each molecule. To find the number of peaks and the ratio of areas, the NMR graph is required. In this graph, the functional groups are shown. For the unknown substance, number 69, I found this substance to have functional groups of carbon, hydrogen, singly bonded carbon, and carbon-bromine. In this graph, the number of peaks and the ratio of areas are shown. The number of peaks is 2 and the ratio of areas is 3 to 1. Table 3 is showing the different functional groups that were found in the unknown substance, number 69. Carbon, hydrogen, singly bonded carbon, and carbon-bromine were found in this substance. Table 4 is showing the number of peaks and the ratio of the unknown substance of number 69. The number of peaks is 2 and the ratio of areas is 3 to 1. In this experiment, we were given 3 unknown substances and used IR and NMR spectrum to find out what molecules the substances were. In the first substance, number 69, the molecule that was found was 1,2-dibromo-2-methylpropane. To find this substance, the functional groups were found on the IR graph, and they showed up as carbon, hydrogen, and carbon-bromine. This matches the functional groups for 1,2-dibromo-2-methylpropane. The number of peaks and the ratio of areas were compared to see if these matched 1,2-dibromo-2-methylpropane. The number of peaks was 2 and the ratio of areas was 3 to 1, which matched this substance. For substance number 69, I found this substance to have a carbon-hydrogen, singly bonded carbon, and a carbon-bromine, which matches the functional groups of 1,2-dibromo-2-methylpropane. The substance also has 2 peaks and a ratio of areas of 3 to 1, which both matches this substance. There are severe health cautions if you were to come in contact with this substance. The U.S. National Library of Medicine states that it can cause skin irritation, eye irritation, and can be dangerous if swallowed. It is harmful if it is inhaled and can cause respiratory irritation and can cause cancer, but it does not have any known harmful environmental factors. These are my references. Thank you.